Hello everyone. This is a review for trigonometric functions, which is sinusoidal function, which mean function that repeat periodically. So the three basic function that we have is the sine function, cosine function, and tangent function. So I will draw them here, and I describe the characteristic of them, like how to describe those trig function, amplitude, period, and all that. And then I'll talk about transformation, how to transform them. And then I will do some practice tests as a way to review about this topic. All right, so let me show you something really cool, which is the graph of sinusoidal function. So look at this here. So in here, I have a sine function, like you see my arrow pointing here. The sine function look like this, look like wave. All right, so the axis is here, x and y. And you can see I'm starting at the 0 here. It go up and come down to 0, go down, come up to 0. And then that's one period. And then the pattern repeat, up and down, up and down. All right? So this is called sinusoidal function, periodic function, right? So they just keep repeating. Example of periodic functions, sinusoidal functions are like weather, let's say rainfall in a city, anything that repeats like tidal wave, swing of a pendulum, any motion that repeats, anything that has season, anything that keep occurring can be modeled by periodic function. Okay, now how do you describe it? Like for the sine function, if you see what is the period, it's come back here. Now this number is about 6.28. If you convert it to pi, it's exactly 2 pi. Pi, pi, like the pi number. So sine function repeat every 2 pi. Every 2 pi is one cycle. It's go up and down, up and down. If I now ask you, what is the maximum value and minimum value of a sine function? So if you look here, you look at how high does this sine function go. It go as high as 1 unit. And it's go at as low as 1 unit. So the maximum value of a sine function is 1. It reach the height of 1 and come down as 1. Now, when we study sine function, this is the basic function. And then we're going to learn about transformation. We're going to attach some number a, b, h, k around the function. All right? And then we'll see how does it affect the function. So a is a number that you multiply to the entire function. F of x is your function sine x here. You apply sine x by a. Now here I have a slide that I can control the a value. Right now a is 1. So which means it's not changing anything. You just apply 1 to a function. But now if I change 1 to a bigger number, as I drag it, see what happened to my sine function? Well, it gets stretched vertically. All right? So, but one thing don't change. It's the 0 doesn't change. Because 0, if you stretch it, it's still 0. Stretch means you multiply by its value. So let me make the a value equal to 3 now. Like you can see, if equal to 3, 0 times 3 is still 0. So that's why all the 0 point, they stay. However, look at the maximum value right now. Here is the maximum value used to be 1, and now it's become 3 because you stretch it by 3. So now it's still a periodic function, but it's hit as high as 3 as low as 3. And if I now make this number smaller, right, the periodic function, it changes. Now, the term that describes the function that's go up and down is called amplitude. All right, see? The amplitude gets smaller whereas a gets smaller. And a get negative, the curve switch to the other side. If I make a negative 1, it will be exactly the opposite of the shape. Okay? So let me bring a back to 1. Now let's look at another function, function b. Parameter b. Parameter b is the number that you attach here next to the x value. Okay, so you attach it inside here next to the x value. And if you do that, let's see what happened to the function. Okay, let me change b value to 2. Wow, look at this. Okay, when b equal to 2, you actually compress the graph horizontally. You have the same amplitude, but the period now become half of it. Look at the red graph is the original graph, which repeat every 2 pi. Now look at the purple graph. Now it is repeat 1 pi and repeat twice into 2 pi period. So when you stretch b, the whole graph will be compressed. Okay, and then like vice versa, if you go the other way, it will be expanded like that. Okay, so it's really, this graph is really cool to see. Now let's look at the h and k value. H is a number that will modify x. If I choose h, what's happened? Oh, the whole graph shift left and right. Do you see? The whole graph moving left and right like this. Okay, if I move completely one cycle, let me see. See, the value I'm choosing is about 6.28, about negative 2 pi. See, the graph completely overlap because they repeat every 2 pi. Now let's try k. K, guess what we'll do, right? K will move the graph up and down. Look at this. Let me summarize it for you. Okay, so let's go to the notes that you can use this note as summary. Okay, to summarize the note, we have three basic functions. Sine function start at 0. The period is 2 pi. They are symmetrical. You can cut the 2 pi into half, which is pi. Cut it in half again, pi over 2, and you cut it in half here. How does the shape look like? Go from 0 to 1, back to 0, go to negative 1, back to 0. That's the shape of a sine graph. So if I describe it, the amplitude is 1. Amplitude means how far away from the center line it's moved up and down. So it moves up and down by 1. The period is 2 pi. X-intercept, you can see is 0 pi, 2 pi. If you keep going, 3 pi is every pi. The way to write every pi is n pi. And then you say n is integer. So which means every pi, it will hit the axis. What's the y-intercept? It crosses the y-intercept at 0. Tangent graph is very similar. Tangent graph also 2 pi period. So you can cut it in 4 equal parts. It has a similar shape, except it doesn't start at 0, it starts at 1. 1, 0, negative 1, 0, 1, and then it's keep repeating. So a cosine graph look like this. Okay, the amplitude is still 1, the period is still 2 pi. Where does the x-intercept? The first x-intercept is here, which is at pi over 2. And then it's repeat every pi. You can see here, every pi it will repeat. So you say plus n pi. So this is how you describe a cosine graph. Whereas the y-intercept will hit the graph at 1. Finally, tangent graph is different. Okay, you also do pi, and then you cut in pi. All right, you further cut it in half, you cut it in half. However, the tangent graph, they actually repeat every pi. It looks like this. I don't know if you need it to know or not, but if you graph in a calculator, you'll see it. So I'll just show you. For the tangent pi, the one period is pi. In between, you have something called an asymptote. And then you start from 0, it just approaches the asymptote like this, and then you go the other way. So this is the tangent graph. You repeat the same thing here. Period mean they repeat every period. It may hit the middle. Start from 0, go to the top. The tangent graph look like this. Okay. When we have tangent, we talk about amplitude. The period, they repeat every pi. The 0, you can see here, they also hit every pi is the 0. Is the x-intercept every pi. And the y-intercept, they hit at 0. Okay. Now for tangent, we have something called the asymptote. This dotted line is called asymptote, which means the graph will not touch. The asymptote started, the first one is at pi over 2, and then they repeat every n pi. They repeat every pi. So we write n pi, which means they repeat every pi. So this is the basic graph of trig function. Now let's learn about transformation. Next slide. So given, let's say a sine function, y equal to sine x. If I want to transform it vertically, you can put a number outside of the function. You multiply by a number or you add a number. Okay, so a and k will affect the graph vertically. If you want to change the graph horizontally, you change the variable x. You change x into b bracket x minus h. Okay, so b and h will affect the graph horizontally. So if a graph a and k affect the graph vertically, which will affect the amplitude of the graph. Like instead of going up and down by 1, you multiply by a. So it will now go up and down by a, absolute a. Amplitude is always a positive number. So even if it's negative 2, the amplitude will be 2. Vertical displacement is how much the graph have moved vertically, how much it has displayed. So we use the value k, is how much is displayed. Okay, what's the period? The original period is 2 pi. Period and horizontal phase shift is about the horizontal component of a graph, so it will be affected by b and h. The original period is 2 pi of a function. If you put a b there, it would divide it by the b value, absolute b. Horizontal phase shift is shifted by h. So let me give you an example. Let's say if I have a function y is equal to 3 sine 2x minus pi over 4 and then plus 2. Okay, what is the description of the new graph? First, you can say the amplitude is absolute A, so is 3. The amplitude is 3. What's the period? The period is 2 pi over b. For this question, what's the b values? Let me write it here, A, B, H, K. Okay, well, let's put a plus sign here. So, okay, let's change the question to plus. So, the period is 2 pi over 2. So the answer is pi. 2 pi over 2. The answer is pi. All right. Now, what is the horizontal phase shift? Horizontal phase shift is the value h. In our form, there's a negative sign here, but there's no negative. So if I want to match the form, I need to change to negative of negative pi over 4. So therefore, the horizontal phase shift is negative pi over 4. You are moving it to the pi over 4 to the, if it's negative, it's to the left. Finally, vertical displacement is a positive 2, so it's 2 unit up. Okay, so this is how you deal with transformation. So let me give you another formula to find out amplitude and vertical displacement, or like the A and like K value, which is, you can memorize this formula. When you look at a graph, when you find the maximum value minus the minimum value, and then you divide by 2, that will give you amplitude. Okay, when you have a graph, right, the maximum value, minimum value, you subtract the 2, and then divide by 2, that will be the amplitude. Now, you have a similar formula for finding the vertical displacement. If you have a maximum, you plus the minimum, divide by 2, it will give you the vertical displacement. Okay? So just memorize those formula. And now I'll just give you another example, and then let's say I have a graph. All right? So let's say I make a graph here. And then the maximum point is 8. The minimum point here is 2. All right? And then from top to top, let's say it will span pi over 3. Let's say that's the period, right? From top to top, that's the period. If I ask you to write the equation about this, all right? So let's find out the value. A is max minus mean divided by 2. So max value minus mean value divided by 2, the answer is 3. The k value, or some may the book call it the d value, is you add them divided by 2. So you add them divided by 2 is 5. Now what does this value mean? It means the whole graph has been shifted up by 5. So if this is the axis, shifted up by 5, you draw a line there. That's how the graph has been shifted up by 5. And the amplitude is 3, so it's go up 3, go down 3. Look here, from 5, if you go up 3, it gives you 8. Go down 3, give you 2. And what is the period? The period is pi over 3. Okay, period is equal to 2 pi over b. So if I now work out the b value, b value, if you double this number, b value will be 6. Okay, finally, if you look at this graph, it starts from the top, it go down. So the final answer is this is a cosine graph. All right, and I'll put the a value there, put the b value here, and put the k value here. So this is how you write the equation. If you type this equation in your graphic calculator, you'll get this. Make sure you put in radian mole. Okay, I'll make another video to go over some